Check. Hello, everyone, and welcome to my stream today. How are you all doing today? Say hi in the chat. Let me know you're alive. I realized I watched back a couple of the last videos, and I've been missing my trademark drink, so I'm bringing it back. Although this is a little different. It's not lemonade. It's suja, which has lemon and cayenne and a bunch of stuff in it. But all right. Sorry, my audio doesn't sound quite right. Oh, my mic's a little quiet. Is that better? Yeah, that's what's going on. Still getting used to the new setup here, but I think that sounds a lot better. Yeah. Okay. Cool. Check. Okay. All right. Okay, we're gonna get started right up here in a minute. I'm just gonna open Twitch and make sure we're going good over there as well. All right. Nice backdrop, but you can't trust me after that green screen. Yeah, I mean, this is my actual backdrop. To be fair, that green screen was my actual office in a different room. As you can see, I have the same Lego on the shelf. I haven't rebuilt my Zelda collection yet, but we got the Ghostbusters car. We got Optimus Prime, Grogu, Porsche 911, Nissan GTR V-Spec, and a bunch of other small ones. We got Groot back there, and Mini Groot and Rocket, and yeah, anyway. Might even see Kelvin and Hobbs at the top. The first actually, the base is actually a knockoff. I just keep it out, not for display. It's just like this could have a base out. It's like a cheap. It's just a cheap Fender knockoff that I got at a pawn shop one time. I don't play bass very much. Maybe just when I'm recording some stuff on my own tracks. Yeah, Mr. Sol's right up there too. Yeah. Anyway, how's everyone doing? I'm back again after a week, like kind of old school style. Well, it's because I accumulated so much stuff. I ran out of time last week. I've been doing lots of research, a lot of work. I don't know if anybody got the chance to check out the example that I posted about 40 minutes ago, but it's kind of a hint at what we're going to talk about today, obviously. I think this is, as usual, a very underdeveloped topic. You tend to get there when you're working on stuff that people haven't tried or seen before. It's a tricky balance, I find, as someone working on this stuff, because like Solid 2.0 isn't out yet, so it kind of sucks to be showcasing this stuff and you being like, can't I use it? Can't I use it? And it's like not really ready. I was fixing bugs like up to an hour ago or so. Like and there's still probably more bugs. This is just a kind of proof of concept. But on the other hand, it's important so that the knowledge starts, like, so people can start understanding where these things fit. I don't know. For me, I've generally have a fairly good measure when I start like talking about stuff or hyping up ideas. It's basically when I have a prototype. When I have something that I can show, that's the line I draw. I find nothing more frustrating when people talk about some amazing thing that sounds impossible. And some of the stuff I show you today might sound impossible, but then have nothing to show about it and be just like, oh yeah, we solved everything, but I'm not going to show you yet. Just get hyped. I think that's, I don't know. It doesn't sit right with me. I know people come by it naturally because they're really excited about what they're working on, but it's like, I had to deal with this with benchmarks already in the past. Like basically, until you prove it, it doesn't exist, as far as I'm concerned, which is hard because it sometimes it creates a lot of noise, right? Like, God, like just trying to navigate through this past week has been a little bit fun, right? The remix guys are back at it again, still saying a bunch of stuff, have nothing to show, and at the same time, use it to try and position things such a way that they're calling out negatives on other solutions and stuff when they have no like they have what I mean, they have nothing to actually back up what they're saying. So it's kind of like you kind of like breeze by because you're like conceptually, until they show something, there's nothing worth talking about. But then on the other hand, it's kind of like they're spouting a lot of stuff, and you're like, maybe someone should kind of fact check them on that. You know what I mean? It's interesting. Looks like those limited edition precisions with a jazz neck. Yeah, it does have the neck contour more of a jazz bass, but yeah, I think the it's a pickup setup more of a P bass. Yeah. All right, all right. Have I killed enough time yet? Maybe I should tell the people on Twitch that I'm live. Or no, I stream, sorry, on X now. So it's really only the people on Blue Sky that don't know I'm live. Maybe. Let's do what? Twitch TV/9 solid. All right. Post. Honestly, I don't know if there's that many people coming over from Blue Sky, but yeah. I'm pretty excited about the topic today in general, though, because I think it's one of two really major developments that I want to see kind of like, how should I put it? Like, I want to see this exploration in these two areas go a lot further than they have historically. I was talking to someone earlier in the week about Solid, and they were like, it was off one of the like remix threads again, and they were like, I think React has shown one way of doing things, Solid has shown another way. Both those ways have hit their limit. If we want to do something else, we need to do something different. And I'm like, kind of, but I don't feel Signals and fine-grained reactivity have actually gotten to where React is along the path. Like, I feel like Solid 2 is a little bit like React 16. Like we're still at a point of refining, right? You know, I'm not saying that APIs are going to change or something going to introduce a whole new way of doing things. It's more just like there's little details. Like, I don't know if you remember back in the day, even I guess before React 15, but like sometimes that state would update the state right away. Sometimes it wouldn't. There'd be like little inconsistencies, and we've ironed a lot of those out. But React 16 was a big deal because it basically allowed React team to rewrite the core from scratch the way that made sense with everything they had learned the last 5 years. And that's kind of where I'm at right now. Of course, React's a much bigger team, more people using it even by that point. So they progress a lot quicker. I think Signals and Framework and this kind of fine-grained architecture still have another 3 to 5 years before they kind of top off where we are on the current technology, right? I'm not saying it won't. It's funny because React's kind of gone as far as it can go in a certain way, and that's why like we're getting to RSCs and all that stuff. I think you'll know when Signals get there when everyone starts talking about resumability. I think that's towards the edge of where these models are. But until we get to that point, and that's what like is the defining feature, I think there's a lot of areas that we haven't explored in these two specific areas. Async, which I talked about a ton on my Signals 2.0 stream, and then mutable state or mutable reactivity. Anyways, let's get started here now. I'm gonna kind of flip over because basically I've been working on HackMDs. I'm not going to hopefully drive the whole thing off HackMDs, but I wrote a lot of stuff about stores and projections the last few weeks because I kind of realized that while we had certain characteristics that were right and we're on the right path, the implementations weren't good. and there was holes, and it made me rethink the whole thing. And I think finally in the last couple days, I've kind of solidified on what I think the characteristics of these primitives are. It sounds crazy to spend so much time working on like one primitive, so to speak, but it's really important, right? Because the idea is that you can do a lot with only a few simple building blocks. So the more pressure you put it on that way, the more powerful it needs to be, right? So you have to kind of start going, do we break these apart into different primitives? What is their core philosophy? What is the most sensible way that they should behave? Okay, so yeah, I've got some write-ups. They'll help guide our discussion today. I've got a bunch of examples because I've been playing around, including the one that I posted up on Blue Sky and X not too long ago. But I think this whole discussion starts with like, why mutable reactivity, why stores in the first place. And there's basically only a couple options here when you start looking at the problem space. And I'm actually going to pull up an article that I saw earlier. Where is it here? Sorry, I'm grabbing my bookmarks. Yeah. Jovi, if you don't know, instrumental in on Preact in terms of the signals implementation in Preact, and kind of is looking at this. And I think this is a great article. It's going to also serve a bit as the base of our discussion here. And I'm going to just post a link here. Software is ugly. You have to embrace it. I'm going to want to talk about that in a minute here, but I think I'll leave it a bit later in the stream. It's just, I think what you're going to find over the course of my discussion today is there are a lot of challenges with trying to beautify at the cost of semantics. And part of the reason I've been able to do all the work I have so far is because I didn't try to warp JavaScript to my own semantics. I understood what I wanted and then understood what I could do with JavaScript. And then everything sort of flows from there. If we had made signals and stores into a single primitive, the way Svelte and Vue has, I probably wouldn't be here on projections. If I'd gotten rid of the wrapping functions on computed or memoized values, we probably wouldn't have landed on projections either. Like basically, there's some kind of truth in the physics or mechanics of things that if you get too far away from it, like you just keep on hitting back into it. It's like there's like rivers or like technologies discovered, not invented in a sense. Like there's a certain science behind it. Like, and if you keep on trying to like patch the holes to make it beautiful, sometimes you actually end up making it harder down the road because you like really tried to steer the boat off course, and the boat was going to go that way anyways. Like the river was already there. This is obviously some of my tension that I have with something like Svelte, and I think by the end of the stream you kind of understand like why sometimes it's just not worth it, and you have to be very careful understanding the difference between, say, using compilation for semantic to optimize and using compilation to warp the semantics for, say, making things easier. Because the first doesn't change how it like appears to work, right? Like I'll give the React compilers some credit there. They're trying really hard to make it so that when you look at the code, it works the same React mentality with or without the compiler. Now, don't get me wrong. If you look at the code that you'd get from the React compiler without all the memoization and you just ran it, I mean, it would be the worst thing imaginable. If React didn't have that compiler, didn't have the VDOM, it's literally the worst mental model you could probably think of. It would be like when you understand the DOM, right? You're literally like, let's just recreate everything all the time, just write some state, follow the control flow, play the Plinko machine, do, and essentially, state update, do, like essentially get to your end result. But that's how React works. So the fact that there's memoization, all that stuff added under the hood is just a benefit. So by removing the syntax and actually just doing it, it keeps the React mental model and doesn't warp what it's actually doing. In a sense, you could say, oh yeah, it's hiding that it's memoizing and guarding all these values. But the code you read is effectively doing what you expect it to do to a certain degree. Like you're calculating values and writing this function that runs this function that runs this function, follows this branch, follows this branch. It's a very different thing when, like people might have this complaint about solid JSX, right? Like if you don't realize that our templating wraps the holes in functions, you would have a pretty hard time because it's kind of warped your perceived semantics of what the templating is doing. That being said, JSX officially has no semantics, and we could have not used JSX. So, we're acknowledging that this is a different language, and I think templating is a bit long within that area. But if you write something that looks like JavaScript and it has different semantics, like you remove function wrappers and know that, you're in a different territory now. And you're basically saying, look, I've created my own language that's not JavaScript. And if you're trying to like stay in line with JavaScript, you're again kind of paddling against the river. You know what I mean? So there is a certain bit of it that like recognize that, say, JavaScript is ugly at times, and you will see the truth. Yeah, we'll talk about it. I mean, when we were working on R3, we were looking at using non-store primitives, but there's something about the shape of the problem that gets you back to stores, right? I mean, Jovi's article is actually going to be really helpful at looking at this, I think. But yeah, like what I'm trying to get at is we have to be careful, right? Like my classic example is I used to make that meme joke, where I mean, I could probably find it. It's on one of my talks. What is it? It's like in a number of my talks, where solid talks. Sorry, give me 2 seconds. What's it? World Beyond Components. Sure. Where it's like towards the end of it. I sometimes do this thing where like, look, a component's a function, right? We can do magic, right? Like sorry, I think I have an earlier version of the meme. Right. I have it here. Everybody's seen this. Everybody's seen this meme, right? Where like there's like all this React stuff, and then like Svelte like this, right? But the challenge is that just because you write this doesn't mean it's not actually this. So like this is an example of what Svelte does with Svelte 4 or 3 did with count is not how JavaScript works. This might be clunky as hell, but it is actually how the React model works, right? So like to a degree, I mean, you could say that the hook's a little magical, the way like the re-render model and the way it hides in the background. But my point is, like, if we are like one of the cool things about signals, you do this, right? But if we're this, we've we basically removed the language to make like express the idea, because we were focusing so much on kind of this short-term gain in ergonomics that we basically were like, okay, we don't want to flow downstream, let's dam the river. And it's like, well, you're never going to get downstream then. What are you going to do? Walk along the side instead of just taking the boat? So we have to be very careful with what we use compilers for, right? And the end result of this was Svelte went through a breaking. I mean, you can still use Svelte for components, but Svelte went through a completely breaking API change, right? Like, it happened because went too far away from the physics of it all. And this is something you have to always be kind of conscious of when designing these systems. Anyway. It's just, I don't know. I know this is a bit of a tangent before I get into things, but I've just been realizing through all my, like, I've been talking a lot about education and mental models and semantics, and it's kind of crazy, right? Because like the baseline React semantics, when you remove all the hooks and all the memos, is conceptually, as I said, like the worst thing you could be doing, right? They have all these tools to make it actually work. That's what React's so amazing, because it works reasonably performant, right? That's what makes React amazing. It's the model shouldn't work, right? Like conceptually, right? The compiler, the BDOM, all these are tools to let you just kind of write this system. But if we live in a world right now where people look at React code and they're like, oh yeah, that's a norm, that makes sense. Like, no wonder no one understands how anything works, because if you look at the model that shouldn't work and say, oh yeah, that makes a lot of sense to me, like, and you don't have the background and experience to like understand how these things work, like you're already starting from such a weird deficit. Like if you get trained on like, this is the model, how could anyone make sense of how things actually work? I think it's an interesting thing, and we'll probably talk more about the state of like frameworks and perception and web dev when we get to This Week in JavaScript later. It's just kind of walking along this pathway of semantics and syntactual like meaning to what we write, and the impact our frameworks and tooling have on this. It's kind of crazy to expect people to actually understand the fundamentals of the web if literally the opposite abstraction is the baseline that is how people learn these days. In your opinion, React exists only because this syntax, you mean like this, like the keyword, like class syntax and the way bindings work? It's kind of funny. Like in Knockout, you just fat arrow everything and then like everything would be automatically bound. The ironic part about that is it actually led, like it actually led my old Knockout code to put everything in the constructor anyways, which moved us to functional components and off classes anyways. It was just like this ironic thing, because you basically have to call bind or use the fat arrow and CoffeeScript or whatever to actually get the binding to work the way it does in other like OOP languages. So it's like almost to the point that you end up like not using the classes. It's kind of crazy. But yes, composition patterns were awkward because again, React made sense to have the life cycles, and then this was tricky both for this dot set state, but also for like binding event handlers. It was just like the source of confusion. And the funny thing is, historically, people working in JavaScript kind of understood this to a degree. There is a thing, but if you can just remove that conception, that thing, it makes things simpler and easier to approach. So in a sense, hooks were designed to sort of warp the semantics a little bit. So I mean, like, I'm not saying like anybody's not guilty of messing around with things a bit. It's just like, is it a wrapper? Is it a compiler? Like, the further you go down that path, the harder it is. Like, the stronger the wall you put it that could possibly impede you from going down that path in the future. Well, I mean, it's the reason they came to classes is kind of, again, Jovi's article is quite good, and I want to get to that in a minute, because like the reason they came to classes was because of one of the like biggest weaknesses of the Svelte 5 design, which I've talked about before. It's like, it's all fine that you're pretending like you don't have to worry about portability and reactivity, but like the problem is, I'm just gonna use the solid playground because it's in front of me, but it doesn't really matter. I can just clear this out to write the code. If you go something like let state equals $state something. So this is your signal. So you're making some kind of like hook, let's say function my state, right? So you're looking at composition patterns. So you did this, right? Makes sense. Because the way that this works in Svelte, you don't call it as a function. The compiler manages that for you. Technically, these are functions under the hood, but the compiler manages to you. So you remove that semantical part from the language. But then if you want it to like leave, you can't just return it, because any access to this thing is actually the value, not, it's like the compiler makes that this. You can't pass the reactivity through. So, view ref sugar was like, okay, let's like do something like this, or actually on the way out, it's like this double thing, and they start coming with weird semantics. And at a certain point, you're just like, freaking wrap it in a function, right? Like, God, right? It's a function, make it a freaking function. Sorry. But when you did this, people are like, what the hell? Why would you wrap a value in a function? Like, it's because secretly you have to know it's this. Like, but this makes no sense. So Svelte just needed to find a syntax that was obscure enough, and it's funny, classes have become obscure enough that they could like basically let you write the stuff in kind of like a declarative object, like basically define the getters, and they could go in and wrap all the functions for you. It's kind of like what we do with JSX, right? They just needed to find a syntax that was explicit, like this is what I want, or because wrapping with a function is not explicit enough to say this is what I want. Like, it's anything could be a function. They needed something like that was like statically analyzable enough that they could like look at it. And that's basically why they ended up with classes. It was just to hide the fact, like the whole thing is because the problem with my state is now when you're in your Svelte component, you would have to do something like this: const my state equals, state equals my state. And then people were like, well, that's kind of awkward, because now you have to call it like a function. Do you know what I mean? Like, this is, what is this, solid.js? Or like even better, again, because you can't mutate a variable you just pass back. If you want to set it, maybe you did something like this. So like, now don't get me wrong, all these APIs are similar enough that they're interchangeable. You can use views, but the problem was that their core primitive, the baseline primitive that you're expected to use, doesn't compose. It's a language feature. And this is very common, that baseline language features don't compose and can be intentional. Like, and you can't make your own if statement or for loop. You can make a map function, but you can't like make your own, like, syntactically it belongs to the language. with runes, Svelte was like, what if we had a reactive language where it syntactically belongs to the language? This is what it looks like, but it means composition becomes its own thing, right? You can't make your own for loop, you make for each or map. It has to take a different form. And it's a repercussion of going this direction. I'm not saying necessarily, there's lots of repercussions of going this direction, actually, if we continue down the path we're going to go today. But I just kind of want to point out that we end up with classes here for like the most indirect reason. And it was basically because we were fighting JavaScript. I see this a lot in the proposals too, even people who use like, state.value, like view or preact. And it's like, at a certain point, like this is all fancy, it's a getter, that's all nice, Sometimes getters are nice, especially when you nest data. And we'll talk about that today because we're doing mutable nested reactivity. But the problem is, even if you support this, you have to be able to support the function call, because if you want to move this around, you're going to do this. You always add at the baseline, regardless of all these other mechanisms, a signal is a function. You can wrap it up, you can come up with a different syntax for it, but anything you do ultimately has to support this. And this wrapper isn't going to necessarily pass your is signal test, because it is like reactivity is transitive. So any function is going to potentially be reactive. So there's this whole idea of trying to define the state class, whatever, like, is basically all nice, all convenient, all these different ways you can do it that introduce the syntax. But ultimately, I'm sorry, guys, it's a function. Get over it. There's no avoiding it. Hooks are invented to tell React where state and specific logics are. Otherwise, React wouldn't know what component is doing. It's a black box to React. Well, React still doesn't know what the component's doing. Just to put it out there. Internally, and you see this when you see state libraries like Jotai or whatever, people are just making a state, like a use state, and they're just going flick. There's like rerun it. React doesn't have, this is why I use the Plinko board example when talking about React. React has no clue what happens. You're just like, invalidate this component, and then it's like, okay, I will figure it out as I go. Like, I realized this. I was like trying to explain the difference between like signals architecture, which is more like marble run, where like everything's kind of wired through and like goes, and like you might only go down this side. Like there might be a drop that just drops straight down. Something else might like go across the whole path. Like, don't get me wrong, looking at it might be a little bit harder at first because you're just like, oh, how do I traverse the thing? But on the other hand, the framework or the technology knows where it goes. There's only so many places it can go, and it's all isolated. React's Plinko board is kind of like, okay, guys, I know that here's the top of the machine, so I'm just going to drop the chip and, at every decision point, figure out which way it goes. Hooks fake the state with destructuring classes are just more now created for. Yeah, I mean, I get it, because yes, classes, see, this is the funny thing. Classes make sense for React because each component owns its own state, and that's the thing that revalidates and renders. Classes make sense for reactivity models, but not fine-grained components, right? So, I mean, this is why it makes sense, like to a certain degree, why you might want to use classes. The only problem with classes is I wonder if it's the best way to model complicated logic, like complicated data structures. You can do classes of classes and classes, and honestly, it's practical. Like, there might be like practical reasons for that, which I'll get into, but it's an interesting. Oh, nice. Vapor Alpha is out. Good to know. Thanks. Oh, you just want to, I mean, people are trying to, the problem, sorry, just really quick kind of tangent. The problem is um, signals are the observer pattern. They link both ways. The observer is aware of its dependencies. The dependencies of aware of its observer. And the reason for this is when dependency updates, it has to tell the observer. So that one's like a given, right? People subscribe to the dependency. But the other direction is important because when the observer reruns, it shouldn't keep its history forever. It should like dynamically create the dependencies. So like usually there's a cleanup function that it basically has a way that for the observer to go like, okay, I don't need you anymore. But like, and there's been clever ways of trying to use weak maps or weak refs as a way of keeping those links back and forth so that like if one of them drops off, the other one can go. Because the problem is if you have a long lasting signal, that derived value will never go away, even if it was created as part of some specific tree, unless you manually get rid of it or you do a trick like no one's listening to it. But effects especially, no one listens to effects. They just exist and they will never go away unless you manually dispose them. We solved that a lot of modern frameworks of fine-grained rendering by using the ownership model, which pioneered by like Surplus and is used in Solid, and we're now seeing in all the granular fine-grained renderers. But that being said, the proposal isn't that far. It's just the basic mechanism. So they're trying to like keep those links in structures. First of all, maps are too slow to begin with. If you look at it, like alien signals use linked lists. Solid uses 1.0 uses plain arrays, but but uses like a smart way of like not reallocating and like shifting stuff around. Like this is a performance critical part of it because of the double linking, and weak refs and weak maps are just slower to access. I've actually had some trouble with store designs around this. Like there's places where I'm like accepting of the performance, but other places where it's tricky. Generally speaking, weak maps and weak refs are lower, and when they're in a hotspot, this is actually a noticeable thing. So that's why there's concerns there. Yeah, I mean, classes are great, but I'm going to talk about stores because I think stores remove 90% of the use case for classes. Yeah, arguably, but I think it's also the shape of the problem. I think. Yeah, yeah, okay, yeah. So they're doing it all in one. I mean, we've seen what this looks like already from benchmarks. They've been leaking this for like 4 or 5 months. So we've kind of already looked at this, but yeah, this is when they like this is modern view happening, which is very very cool. Okay, so I guess I should just get into Jovi's article because I was going to talk about increment like part when I said that earlier. There's basically two ways to go with it. I wanted to kind of get one of the ways out of the way that isn't Jovi's article, which is incremental computation. The problem is like pretend you have a big list like to dos and and that's not even a big list, but pretend you have a list of objects that have certain properties on them, so it's a nested list, right? And you put that in a signal, and we actually have, like if you go to the solid.js website and you say like the store example, we actually have, where's the tutorial, and we have the like why do you store thing, right? Where's it stores nested reactivity. We actually show basically Jovi's article in here, but the problem is like if you don't use nested reactivity, this is what you have. When you add a to do, you clone the list and add the new to do. When you toggle them, you map over it, and again you have to clone the list and then put the new item in. And this is because most of the items in the list stay the same, but you basically need to like, sorry, I said basically multiple times. You need to create a new object here because otherwise, like if you just mutate it, no one knows anything changed. The signal is immutable. This is one source, so you have to make the change at the source if you want it to do it. And if you just mutate one item here, we can't use referential diffing. You have to use a key or be keyed by index, essentially. Like if this is an interesting choice for solve that we have our for component, but the idea is if you're going to go down this way, we expect you to preserve immutability. By cloning this object, we go, okay, in this for, it is a new object. That's the one row we have to re-render. So it's smart. It goes through and it if I go through here and I look at the console logs, if I remember correctly, and I click, something like add to do, we're going to see creating this. And then if I add another one, it's only to create the new one. It didn't recreate all of them, right? But every time I change the state, it's also recreating that row, which is kind of wasteful, right? It's because it has no choice. That's the only way it can communicate the change, and it needs to do it immutably, okay? So the reason this works at least reasonably decent is that for is doing a diff. It's doing a very basic diff, a shallow referential diff. It goes have the reference changed, recreate or not, right? In React, it actually recreates all the rows, but they're VDOM, not real DOM. And then it goes through and goes, do these keys match? If they do, skip. Well, it's not skip, it's actually dig deeper, but it's not like a replace operation, right? See, what's interesting about a referential loop like this is we can skip. We can go, it's the same exact object, which means you're not mutating because this is immutable. We know nothing below it could have possibly changed. Whereas in React, because it's key-based and it's a new thing every time, like you just map over it, they don't know if anything further down has changed. They can go, okay, we've matched up the things. We know that this item is no longer in the list. We can get rid of it. We know this item's new. We can create it. But when they match the keys, they have to be like, okay, well, it's the same object, but it could have changed. So let's keep on diffing. And eventually it'll go down and see that the to-dos change and then update that one place in the DOM, which is cool. Because comparatively here, this naive approach with solid or fine grained render actually recreates the whole div. A lot of people get by on this with cheap stuff because creating one DOM element is more expensive than updating one attribute on something. But people get away with this. It's not great, but it's like the baseline with signals. But this works, in React because React is a VDOM, right? Because when it goes in, it actually does more diffing than R4 does. It's a deep diffing system. Now, what if you're not going straight into React? What if you have other things? Like you have a filter. What if you're doing other operations and you're like, this is very wasteful that basically at every step of the chain, I have to clone the tree, then diff the tree, then clone the tree. And then like you end up with this like diff of diff of diff of diff of diff kind of to know what changed, just to eventually get it to React, where React's going to re-render everything in the VDOM and yet diff again. Like this is the whole cycle. So the solution was the best one that I've seen that I can point to is Signia. That was created by TLDraw, right? And docs. Incrementally computed signals, okay? But you have to understand two things about incrementally computed signals. It lets they still calculate the diff and pass it through, and it's one signal, chain of signals. But what it also does is, diffs don't come for free. They also pass down the diffing information, which means that generally when you write your code, you actually start writing stuff instead of just like adding something to an array. Or like the beautiful thing about an operation in a immutable diffing scenario is you just have the function or next state equals function of current state plus input or action or whatever. So you just have to describe what the next state is, which in this case is add to do, clone the list with another item on the end. like this is very declarative, very simple to write. The problem is if you need to describe a diff and compare diffs, you're actually going to be like add this at location this. Don't get me wrong, you can make object form. Immer has a diff like pattern that's like close to the standard, but essentially you're describing this change and it has to pass through. Now, there's one other problem. Diffs, these discrete changes are events, right? See, when you do this, every time you add it, you actually change the state. So the first event comes in, oh, I'm adding a to-do. Now to-dos from this step forward have this extra information. Comes in again, another to-do, and that's your projected state. It actually encodes that information. That's why it's doing all that work. But if you're communicating in diffs, you have to make sure that anything that could possibly need that in the future has it. So you can't just communicate in one diff. You have to keep a history of diffs because signals might be lossy. You might be reading the state now and then not reading it later and then coming back to it. Like there's gaps. And even in terms of communication, like it only cares about what the current state is. So in a sense, because you can't lose the diffing information, otherwise you don't get the correct state. You actually have to keep a history. And you can't just only communicate in diffs because do you keep an infinite history? Like eventually something has to reconcile down to the value. So like, if you look in here, they have this whole thing where they're like, history length equals 10, right? That's reasonable. And basically saying if it gets past 10, we just bail out and do it again. That's a reasonable approach. Don't get me wrong. But like you're writing much, this is map array function, by the way. This is a way of like mapping something without running all the items in the list in a generic way, like kind of like what you get in our for component. So, but it's custom because you can write your own logic here, right? But what my point is, like, it's difficult at times to write stuff as diffs. You need to create history, you lose events, and you're still dealing with one signal, which means that like everything still gets notified. The big advantage of this is with communicating diffs to diffs to diffs is in theory, you can use that diff information to create smarter diffs down the chain, which means that ultimately, instead of like actually making the projected value and then diffing it again, like going through the process of comparing the values and making the value and diffing it again, something like this could allow you to make the next diff, like the description, like the patch notes, like add this, remove this from the patch notes coming in as an input. And so instead of actually doing a diff operation, you just basically create the next diff and patch it. So it's more efficient because you actually save on doing diffing along the whole tree. You just communicate in these patches. So you get the next patch information, create the patch for you from the parent, and then apply that to your own data and communicate your patch down to anyone who listens to you, and they can create their own patches from your patches, and then so on. So this is an efficient way of managing the fact that the state's immutable. And if you see here, like this method, they're using like immer to do the diffing, which is a great immutable library for doing this because it makes it easy. Because what's cool about immer, even though you're not seeing it here, because it's like literally you're talking in diffs, you're like, if it types a number, if the operation is add, you know, like because if the operation is replaced, like, but what immer generally does is it lets you write things in a mutable way, and then it just automatically produces the right immutable objects for you. So like under the hood, immer might do this cloning and map function and cloning and all this stuff for you, but you just write like todos.push or todos one.completed equals true. Like it basically saves you from writing this. So it's even more terse than the immutable operations. But ultimately, once you're in diff territory, that's not the API you're dealing with. Like this says that it's using immer produce with patches, but does this look like immer code to you? No, you have a big switch statement to handle the history of events and then apply them and stuff. And don't get me wrong, this is kind of like how optimistic updates work a lot of times. But and this is an improvement because you're not you're not realizing the data just to diff it again, to create the diff, to realize it, to diff it, to realize it, to diff it, to realize to diff it. You're actually, for the most part, going down just on these patches, and then it goes all the way to the end. So there's benefits here. There's still places where I think when you're coming in for an event system, converting them into patch descriptions and getting them in, it actually makes a ton of sense. It's just, I think we can do better than try and keep everything in a single immutable signal. The reason that it makes sense here is because ultimately, for Signia, at the end of the line, after they do all this work, they know that they're feeding back into React, which means it's all just one big tunnel, and React's going to diff it again anyway. So it's like they don't get any benefit of making this more than one signal. No. Linked signal is like a writable signal. It's hard. It's funny because, as I said, we haven't released installed 1.0, but I've been talking about this concept for like 4 years now, and it was just something that like I didn't bother releasing 1.0 because someone could just go literally write it in 2 lines of code in solid, but like I didn't have a reason to because I hadn't consolidated the APIs. I hadn't got to a point where I was thinking of it as like just putting a signal in a memo, where if we viewed around and say that some signals are tracked, and we'll get to it, some stores are tracked, so they're actually projections of stores, then it gives an API. But stores themselves are different because a linked signal is still just one signal. It still has these characteristics that if you, sure, you can derive it from something, but it still returns the next value, the whole blob of it, right? Like signals, same thing. Someone has to diff, right? So yeah, it's not quite the same thing. Yeah, I don't know. Every benchmark that I've ever done with weak things has been slower every time. I was trying it just like 6 months ago when I was first working on stores, and I was like, yeah, definitely slower. I don't know. Yeah. Like it's like when you do stuff with like CQRS or whatnot. Like dev loves this stuff. Just like there, it is incredibly powerful way to model things. I'm just saying that like at your baseline in the signals library, I had to see if there was an alternative, right? Well, there is an alternative. Instead of having one signal, have many signals. But there are consequences of this, right? So I've covered a lot of this in stream before, but again, we need this kind of baseline thing to be able to talk about this, right? So, okay, so Jovi, Preact, core team, big part of this, the optimizing the signals implementation in Preact, right? Let's look at what the alternative looks like. Because the funny thing about the alternative is this is what I used to do in Knockout, right? So I didn't have this hook-centric state manager. Those are typical React components. So he's using to-dos. To-dos is a great example. In fact, the React compiler used to-dos too, which was always a really fun thing because I mean this was the point of my whole conference talk. I forget if I show it, but at the beginning of the conference talk, React showed this to-do list, right? But what they were trying to show is that like there's to-dos, you know, but they also added like a bunch of other stuff, right? And like they added like completed and like a color picker and all these things, right? And the problem is as their component got more complicated, with all the stuff, they had to add, memos and use memo and like use callback and all these things to memorize it because changing the color had nothing to do with the to-do list, but everything is, tied together, right? It's kind of obvious that when you have like, you don't even need to go this crazy. You hit this problem in React anyways, because as I said, it literally has to go through all the components, right? Like it's smart enough to not like go into the components when it matches the, well, actually, even when it matches the key, it still has to, like, it's still possible that a prop change could cause the something to update, right? So like, it's, as I said, it's not that simple. And then like this was like their memoized compiler initial run where they showed like no one actually wrote this code, but it like showed like what was going on. And funny thing is, it's actually a lot like Svelte 3 and 4, just an aside note. But what I'm getting at is, this is the problem of making, in a sense, when you have a component that reruns, you're making the whole thing like one signal, or like it's not just the to-dos. The whole now all the state in this component is tied together. And what Joey's doing here, yeah, see, he's doing the immutable change, all this stuff, right? While functional, this approach has several drawbacks. Your components become dumping ground for both presentation logic. Yeah, let's full screen this. State is scattered across multiple use state declarations. I'm okay with that, but okay, let's say no clear domain model exists. Physical concepts like to-do, to-list don't exist in your first class entities of your code. Instead, they're playing, okay. Arguably, it's less clean, especially if it's something that you're going to reuse. Performance is real. Every state change triggers component to re-render, and when only specific part of the UI needs to update. Yes. Right. Like the best case is what I showed, where it just knows to re-render, because props don't change. It knows to only re-render the one item that changed. But even like no amount of fancy memoization even changes the fact that if you are the thing that changed, you still have to run through that tree. You have to rerun the map. You have to rerun like the loop, even if you're just changing a property on an item and not moving anything around. This is unavoidable in the React model here when the state is hoisted, unless you try and pull the state outside, because React has no clue what's going on. They don't know until they actually render it. And for X signal is a different approach. Yeah, I've never seen this approach before. So now look what he did. He made each to-do into its own object with signals on it. And this takes me back to Knockout, because this is what we did. We had domain models made in Backbone at the time, and we would make view models that essentially were like this. If like where you just like basically every time you got fresh data from the server, you would map through it and go, okay, do I already have this to do? If not, I have to map it into like signal equivalents. I have to take the internal thing. Like for a create from the client, this is not a big deal, but picture synchronizing state from the server. Here, each to is self-contained model with its own state and behavior, but there's benefits to this, right? Because now when completed changes, technically speaking, we don't have to notify the owning component of the to-dos that it updated. We just have to really notify the thing that uses completed, right? Here are the two self-contained models, state behavior. The text completed signals can be observed and updated independently. This means we only render the parts that are subscribed to these properties rather than everything in the to list, or we write to do with hooks. So then he's like, okay, well, let's add to-do list. So see how he's doing, like when we add, we immutably clone and then create the to-do, and then filter and this. And what you're going to notice here, I mean, this is perfectly fine. It's just you have a signal of to-dos, and inside this list of to-dos, you also have signals and signals, right? This is how the signals work in the JS framework benchmark. Side note, like the non-store implementation, we basically nest signals and signals. He's using getters here, which are nice because they kind of, now it's just like to-do.completed instead of like completed.value. And it's also nice because now it's not to-dos dot value, it's to-dos Oh, I guess it is actually dot items. But yeah, I mean, this is, he could have just kept this value. It doesn't really matter, but he has to wrap it again because of this object having the other items on it. You can't like merge it into it, right? Like just because he wanted to add these to the to-do list, he had to basically do another wrapper. This is pretty common. And then he added the actions. One comment that I made when I saw this right away is I recommend this pattern a lot in Solid. As I said, it doesn't need to be a class. You can just, this could be a class, but you could return an object. The thing is, I usually suggest returning a tuple because that way, see, the problem is that you can destructure these and you can't destructure these. Some people will be very tempted to just like destructure items, add and remove, and you'll break reactivity. Whereas if you say the first thing is the model or the to-dos, and the second thing is the actions, people are free to destructure it. What I mean by that is people can do stuff like const to-dos add remove equals create to-do list. Now, this is fine when it's shallow, but it gets a little bit more awkward. Sorry. It gets a little bit more awkward in this situation specifically, because if you look at it, each to-do also has like a toggle action and the ability to have a setter, in fact, to set the text. So it has get and set text. So they're kind of like, it's nice this way because now when he gets the to-dos, he doesn't have an array. He it's not like to-do 0 is an array of the model and the actions. This composes nicer, I agree. But it has other implications to get to in a minute. But anyways, let's continue. To-do list, return state model, nodes complete as the compute a signal that automatically when blah, blah, blah. Yeah. Yeah, what's kind of interesting about this, I mean, this is fine. This could have also just not been a computed signal. Like you could just put list.value.length in one of these. It's slightly more expensive, but but you actually see here that there's actually calculations being made and then being wrapped. And I mean, once you're done this work of mapping, you're in much better state. It is a little bit awkward, as I said, is you get raw data from the server, and then like in a to-dos that's client only, that's fine. But when you get raw data from the server and you're like suddenly you're literally mapping models and shallow diffing models to get them into their view model form. But yeah, the benefits in action: use context, to-do list, right? So he's just bringing this in. To be fair, he probably could have created it too. It doesn't really matter because it's signals. And he's showing he can test it separately. He's showing that only re-render this to-do signals change. So basically the to-do item component, and actually I think Preact is smart enough that it actually knows to just do the class name. Stronger than that, when we use Preact, we could even use the box variant of our signal and would directly update the DOM attribute or text note. We can also further optimize granularity by using signal utils like show and for. So it turns out Preact has a mode where it works like Solid, basically. It does fine-grained updates, and it has fine-grained control flow if you use all this stuff. And so your Preact code will look just like Solid, except it'll have a useless virtual DOM tacked on. But technically speaking, other than the unnecessary overhead of supporting also React's model, it looks like Preact actually has pretty much all the characteristics of fine-grained rendering. So yes, this is the win, right? Like basically when you switch completed, it literally only like updates the class name on the list element, doesn't rerun any components. So conclusion: better testability, improved reusability, and has again. So yeah, this is all great. Next time you find yourself writing that, consider whether it belongs in a dedicated model. Right. Well, people hit this all the time in React because realistically, in a simple case, you might do this, but in a real use case, you're going to just reach for a third-party library. What's cool is this is why Solid doesn't have Zoostan and Jotai and all these different state libraries, because people just do something like this. But if you've ever used something like this for a long period of time, as I said, especially with managing data from the server, whatever, you realize that this mapping gets kind of crazy over time because you're always taking something that's not reactive and mapping it to something reactive. It's just like this constant effort. And back in the day, Ryan Florence came up with a great demo to show the overhead of that, the dbmon demo. And honestly, no one bothered doing this. Like, it's funny. I don't know if you've ever seen dbmon, but dbmon paint refresh. I probably showed it on the stream, but let's JS. God, I can never remember the name of the repo. Maybe I got to do it as one word. Can I point? This is Solid's implementation, but can I point it? Did I point it back to? Why didn't I point it back to the original? Yeah, I think it was called the JS refresh, JS paint refresh benchmark. God, God, I almost want to go to Medium and see if I can grab one of my old articles about benchmarking in JavaScript frameworks, because I feel like I've definitely backlinked it there. I thought I wrote one that's like literally like goes through all the different types of benchmarking. It has like an image of Mickey Mouse in it. No. Talk about the 3 types of rendering. No. Oh yeah, understanding JavaScript UI benchmarking. How did I miss this? Yeah, sorry. I turned away from the mic for a second while I was looking over here. Thank you. Yes, this one. It's funny. I'm literally saying the name of JS Repaint perfs, but all right. The reason to look at this for 2 seconds is that sorry, I have to go to Twitch to open the link. Oh, I actually want to go to the GitHub though. This is the benchmark. I think people have seen this thing before, the stock ticker thing. But what I wanted to do is actually find the actual repo. Yeah, sorry, I clicked on the wrong link. Yes, this one. All right, sweet. The reason I wanted to look at the actual repo is that, as I said, Ryan Florence made the original version of this demo. But what's cool about this is you can see how the reason is people look at React, and in React, this is like React create class. Like, this is ancient, okay? Lifecycle render function, and you just describe your UI as mapping over the stuff. And this React version basically just works. Sorry, what's the app component? Yeah, I think these are the wrappers. Okay, like, okay, it's the test render, anyways. But like the majority of the app is just like this table that gets rendered, and you just literally go map. It's like a list in a list. Map. Okay. Now, the reason I mentioned this is this works really fairly performantly. See, Knockout was getting killed here because the Knockout version also did that. It literally just made one observable array, which is basically a signal that updates for each array index. one observable array. So not even an observable array inside an observable array. It's just literally like I'm super lazy, and then inside the thing they like data bind. Where is it? Data bind attribute. Where's the loop? Data bind tr table. Yeah, for each databases, and then they have virtual bindings here for each last thing. So it just puts two loops in, but it doesn't even bother wrapping the other one in an observable array. So basically, it's just like having one signal reblast the whole DOM every time. So obviously, this is way slower than React. But my point is, the reason is to write the performant version of this, where you have an array of arrays. And I've been in this situation before, and you are getting naked data back. Like I've never been in a situation where I need to blast it at like 60 frames per second, but you're getting big naked data back. You need to do better than those arrays. You have to actually literally go through each object, find if you have a reference, maybe stored in like a set or it's already in this array or something. And then if you don't, create a view model where you create observables for each property. If you do, find that view model and then diff the differences in values, and then like compare the update the signals that need to update. But essentially, the code for this is way harder than the React version, because you're not just like doing the declarative part here, which is mapping in the view like this. You're also over here mapping over the data, like a map of a map, and matching it up and diffing it to make sure it works. No one in Knockout basically spent the time to do this. And this is kind of part of why these old approaches died. But it's also the reason that I created Solid.js, because I realized with proxies, I didn't need to map anymore. I could literally create the stuff as I read it in the view and get the mapping automatically. So we didn't need to do this, because like if where is it? Solid DB. The Solid DBmon implementation, and again, this is ancient. I don't know if I've updated this in like 5 years. 4 years ago. Okay. I probably just because I updated to Solid 1.0. This is way older. It's actually just a bunch of for loops. There's nothing fancy here. The key is we created a store, and then we call this magic function called reconcile. And this just says diff the data that comes in fresh from the server every time, and then only notify those signals. And ta-da, we're back to declarative, and we're not manually mapping. See, the problem is, generally speaking, I've been here. This starts good, ends very badly. This is where we got to. Like, I had giant knockout apps that had dozens of these stores, and then you'd create these data structures and they get more nested. Now, there are some qualities of these reactive solutions that I actually quite like. But the part that you definitely don't like is the need to map it. Like, we kind of hint at the Solid tutorial. Like, it's not that hard, but if I solve the Solid tutorial and create, add to do creates a signal, and then it creates like, I'm basically doing what Jovi's doing in this example. I'm basically, every time I add it to do, I actually create a new signal for it being completed. And then, completed, set completed. So I have my action and my read, so to speak. And then when I toggle, I just find the item and go through. This is cleaner. Now, when I do this, when I check it, it's not going to console log that we've recreated FGD, right? So we've won the re-render battle, but realistically, like, this just gets worse and worse as you scale, right? This and this, this and this. And if that data coming in is more than just text, it's objects, you're going to need to compare in very similar way to React. Like, am I dealing with the same model? Compare IDs. Do the lookup. Do I already have an existing? Because the reason is the way these systems don't re-render is that the references don't change. It's the same to-do model, right? With you can't just replace the model. That will re-render the row. You need to go, even if you match on it with the same key, you have to go in and update the signals inside to get the fine-grained updates. And to be fair, React does that same deeper move, but they do it while they're rendering. And here we'd have to manually do it while we're mapping. So it means we map over twice, and that is just wasted work. So this is why I created stores, to prove Ryan Florence wrong, essentially. And I think you naturally get to this point. I think Vue and Svelte have gotten there. I think Preact is going to get there soon. But this is a natural evolution of getting into the reactivity. Now, not all stores are created equal. I'll say that much. So let's talk about that. Yeah. Thanks, Jack. Yeah, sorry. It's hard. I haven't quite got used to my setup. Like, I have my camera here and my mic here. So when I'm talking to you guys and talking to chat, I'm good. But then I go and look over to my computer and it's like echo back to you. I mean, there's always the echo, but it sounds more directed anyways. But essentially, it's because for a period of time, all the benchmarks are basically spamming and diffing. React is really good at diffing. Signals libraries were not good at diffing. They had the potential to be really granular in their updates, but when you make double nested objects and you start doing this mapping and stuff, you could probably get still fairly performant, but the logic just explodes in complexity, which is why, as I said, while Jovi's article is a very good starting point and what people should do more, people in React are kind of already doing that by going to a third-party state library. We needed better tools than just doing that. Don't get me wrong. For simple stuff, go for it. You know, there's a reason this is the fastest approach on the JS framework benchmark, because it's all client side. There's no mapping. When you get to the real world, you need to recognize that there are cases where diffing happens as soon as you leave the environment that you start in. When you're in the same environment, I think you can get away very far without any kind of diffing, right? If you're only on the client, using signals and stuff like this is a no-brainer. It will just always be better than what React is doing. When you're talking cross environment, they have a real reason. And the funny thing is, React started as a cross environment. Before he created React, he created Fax.js. He was thinking about the server right from the beginning, Jordan Walk was. And I think it's not about like being like multi-platform, like supporting React Native and all this. It's about in the same application. And guess what? The web is fundamentally server and client. So right off the bat, this is a good justification for considering that there are diffing problems. Now, the question is, do those diffing problems need to make it into our synchronization and into our UI layer? Like, do they need to be your problem the way React makes it so? And I mean, someone could argue the opposite. By pulling it out, I'm making it your problem. React handles it naturally for you. But the truth of the matter is, we already realized with Signia and incremental computeds is once you're on that zone, you're just carrying it through. It's still your problem. You diff to diff to diff to diff to diff to diff to diff, right? But like, don't get me wrong, doing what we're talking about here is still a huge step up. The thing is, things like Redux, you know, that lend really into React's patterns. For example, like they turn everything into a giant store and then forced React to diff. That's why Redux was so big. It basically was like, look, we trust you, React, and we go all in on you. This is like saying, like, look, we recognize that external state is actually valuable. This is step one. How do we take this further? Yeah, I mean, okay, sorry. Signals can be great cross-M as well if you communicate in smaller chunks, in isolated chunks. A lot of times, the default is here's a big dump, you know, and you know, yeah, there's lots of ways to use signals in React. You can use the Preact signals library. You could technically take solid signals. Legend states, but there's solutions built for it. Legend state and Preact signals are probably the best. That being said, why? Like, it's a different render model. Like, you can use signals kind of like the way Preact is doing it here, kind of pulling the state out. But you could also use Jotai or Zoostand or any other state library you want. React is still going to react, right? Now, if you had Preact's compiler in React, you could kind of get away, with, doing something that's kind of like solid in React, just with all the extra overhead of being React. But then it's like, why are you doing this? Do you know what I mean? Like, React, and you get in the way potentially. React is very unhappy with the Preact signals like JSX transform, because they're like, this isn't how we work. You're messing with things we want to have control with. There's always this like impedance mismatch, which is kind of difficult to deal with, because how should I put it? Like, React has a very different model, and it wants and likes that model. When you're trying to like make components not re-render and isolate update, like when you're just like basically pulling the strings, like you're saying like, React, we don't trust you, we're going to pull the strings. React doesn't get to make the features they want. So like, yeah, you can use signals. You've been able to use MobX in React since the, pretty much the dawn of time. But like, it wasn't the MobX team that became the React core team. It was the Redux team that became the React core team. Like, it's pretty clear that while this is something you could be doing, it's just like, if you really want it that much, you want to do these things, just don't use React. I'm at a point of that. I'm basically saying that we're going to get here. There's an important reason why not unified stores and signals. I mean, we could just put like all stores start with a function at the front, which isn't bad, but I think there's semantic reasons why this is important, because one is immutable and one is mutable. Because the thing that might not be obvious to people looking at this tree. Oh, sorry. I'm going to do that in a minute. Sorry. I want to actually answer Fuzzy. Sorry. I can go back here. I get trapped when I try to use xstate to the pattern and find state machines, which again see something telling not signals or state. Well, the thing is, xstate is like Redux. It's, at its core, it's just a message system of events. But ultimately, when you get to handling state, xstate's like, okay, what's the next state? Like, it doesn't really care how you handle state. So it built itself going, okay, well, we'll just use a mutable change. It's an easy way. We don't need a third-party system. The problem is then you lose granularity. So a lot of the work here I've been doing is making that reconcile work better with things like Redux or xstate, because eventually you will get state, and if it is not granular, in this case, it's the same problem again. Xstate is great at like orchestrating your whole app, but ultimately, when it gets down to it, it kind of assumes React, and it's like, okay, like, don't get me wrong, this is not on David's side of things. It's just he can't cater for each framework. Like, signals are coloration. Immutable data is something that you can kind of just go like, it's immutable and it's good. Immutable data, unfortunately, loses a ton of information because you change a bunch of stuff and then you have to go check it. It's not like, oh, this one thing changed. You actually clone the array, clone the item, and with the new updated property. So right there alone, you did a bunch of cloning, and then when the something gets at it, it goes, okay, well, something changed. Let's find out. Okay, let's go through. I have an array. Yes, this item changed. Okay, I have this. Yes, this item changed. Okay, and all the properties, this property. Like, you're basically forcing it down that path. Eventually, at the end of the chain, no matter if using xstate or whatever, you're going to want, you hit the same problem. So there's an xstate solid adapter, which handles the state fine-grained. It basically, they had to make a special version of stores. I helped them with this. With Solid 2.0, they won't have to make a special version of stores. That's really another thing I was thinking about here. Sometimes you need the diff, because these systems aren't going to be aware, they're on the outside. Ultimately, xstate just orchestrates state change. It doesn't actually responsible for the actual synchronization in the end, which means that it's still the framework's problem. Oh, Legend State does the hacking too? Okay. So, I mean, this is a great improvement, but it's like really, if you're at that point where you're like writing stuff with for and show in React and using these compilers to hack and fine grain updates and stuff, it's like, sweet, I get to still use React. So there's this incremental adoption story, which I think is really cool. But like at a certain point, if you get to a point where you're like building your apps and that's what they look like, you should just not like you should just use something else. Like you're never going to help that technology get like unfortunately you'll do it for your little part and then you'll use a React component library, which won't do it. And you're just basically like do this stuff and you like the pattern because it's good ergonomically. But then like all the other good stuff that comes with it gets thrown away because then you're importing larger React libraries. Or you like basically all the benefits kind of like, except for the fact that you have a nicer development experience, kind of go out the window. And it's just like, at a certain point, it's just like, stop fighting the React core team. They have a vision. Let them do it. If you want something that does something different, don't use React. It's something different. Signals, yes, all signals are based off scheduler. It's push pull. So we push out the notifications, but then we schedule and we pull on things. So yeah, that generally is not a problem. Yes, syntax, sugar reducer. I like that explanation. Sorry, I don't understand. If you're not mutating state, do you still need model validation? I don't understand. Sorry, I don't quite understand. If you're not mutating state. All right, so sorry, I'm just trying to get back to where I was thinking because did I answer the unified stores and signals? Not yet. Was there something else? Sorry, I'm just like rolling myself back up so I remember. Rolling myself back up so I can remember. Yeah, no, okay. It's all good. Yeah, I was getting into mutability and immutability. Yeah. Okay. Thanks. Thank you. Yeah. So that might not be related to your comment, but you actually reminded me what I'm talking about. Okay. Yeah. Rain dish. Unless you know what has changed, you have to treat mutable data as immutable. Immutable data has referential identity, bails, so it's faster. Right. So essentially, we build systems in the client. You always know what's changed, pretty much. But they're at the edge of your system. There might be places where you don't, which is where diffing comes in. So basically, our base primitive is a signal, which is immutable. So our thinking is we expect stuff coming into our system generally to be immutable. That's the rules. But once we're in our system, we can do what we want. That's sort of the basis here. Yeah, I see. Well, yeah, that's kind of the problem. I couldn't do time tracking, time travel. I actually had to store snapshots instead of diffs. But I've solved that. I actually showed this a while ago that I actually have a working version with stores with time travel because I've done crazy stuff. We have to get there though. Sorry, I know this is a lot to kind of get through. What I want to talk about is signals are immutable, granted, but a tree of signals are not immutable. See, like, which kind of gets to my point. This is why you have these nested signals inside. You need the reference of the create to do to be the same reference, because otherwise, like I mentioned this a bit earlier, but otherwise, like you can't trust that it'll update the right thing underneath. The reason you don't have to run the map again with the solid 4 component is because the reference didn't change. It's the same exact object, which means that everything's linked. So when you put signals and signals, suddenly you've gone from something that is immutable to something that is mutable. It is a different type of thing. It has different semantics. Like, it's kind of unavoidable. Like when you write to a signal, you can call a function that's like set this value. And don't get me wrong. When you write to a store, you can also some APIs, have individual writes where you can just like have an object in the right here, right here, right here, right here, right here. But the problem is conceptually, and it can be nested. This always kind of drives me a little bit crazy. But like, if you go like const my store, okay, like I'm gonna pretend it's like view. There's just a single object or something, or svelte or whatever, and you go create store or whatever, and then your store actually has like A, and then maybe like B and C or something in here. I'm just making some kind of nested object. And then we go down and we have a component here, and comp A takes an A, which is store A, okay? And somewhere, sorry, what am I doing wrong? It doesn't matter. TypeScript, because I have no components defined. It's somewhere inside comp A, inside comp A, sorry, we have comp B, which looks like gets B, which is like props.a.b. Now, what I'm getting at is, now inside comp B, and again, I don't know why anyone would do this necessarily. Maybe it gets obscured somewhere else or something. But if someone goes props b dot c equals 5, 6, 5. Okay, why am I so unhappy with this? Oh, it's because JSX can't. I wonder if I can. It's funny. The syntax highlighting is just like really not happy with me having a bunch of top level things. But my point is like, it's fine. This should be read out. If someone does this, it's going to mutate. Sorry, it's going to mutate the object if it's writable. Like, it's essentially, yeah, you could say, oh, we froze the B prop, but because this is like a nested reactive store, it can be deeply mutable when you take this form, right? There's a consequence with now, obviously, you would never do this. You shouldn't do this with a signal. With a signal, what would happen is this would update and when notify anyone it updated. This is bad practice anyways. But like, this technically could, like, if someone's doing something dumb, like locally, did something like const b equals props b, and then they were like, oh yeah, b.c equals 5, and then they use it somewhere else. They're like, okay, yeah, function of b.c, or like with a signal, ironically, you're actually mutating the mutable state, but like it would just kind of like update and nothing get notified. With a store, you somewhere else that's listening to BC, like comp Z over here, like in no way is mutation good, but what I'm getting at is comp Z over here might be also listening to store A.B.C. Like, we kind of get in this like classic mutable problem where it's not clear that some assignment way down here kind of triggers something way over here. It's like it's basically the reason why we all hate two-way binding these days. Thank you, chat. Well, I mean, you can easily make props shallow read-only. Make them deep read-only is a little bit more tricky. Why would you put a signal inside a signal? Just use the effect, right? No, well, it's you put the signal inside the signal so that they're independent. This is what I was showing earlier in the stream. Like, it's the same reason why Jovi wrote this article. If just to clarify, in case someone didn't get it to this point, like, the problem is if you make the whole thing one signal, you're going to rerun the whole component, the map function, everything, because you changed to-dos. If you make a to-do model where each part of the to is a signal, and you put that inside a signal of signals, like a to-do array signal, now if you update the array, yes, it'll update that signal and cause that part to rerun. But if you update just the completed, it can, in React's case, maybe it doesn't work the same way, but where is he showing it? Fine grained render. But in Solid or in Preact in this case, it can actually update just this div element. It doesn't need to rerun any components. So basically the reason is, in a more mechanical way that you can see, is that because you can nest effects. Okay. It's because you can do this, because you can go const b equals a. So I'm sorry, I guess it's a equals whatever. As single a equals a, and then you can go create effect const b equals a dot b. So I'm just okay. And what it means is when B updates, only the inner effect reruns. When A updates, it basically throws away this effect and creates a new one. So you get this tree-like hierarchy, but it's not in the components. It's in the data, essentially. Like if you ever seen what Solid compiles to, it's basically like something like this. So the fact that you have nested signals means that you have nested effects. So these can update independently, okay? Which means you can do much less work. It's not where the state originates, which is like up here, that matters. Or actually it's probably up here where someone was like const, SA equals create my thing. In React, it has no choice, but every time you update my thing, to run everything below it. It can memoize, but if the thing itself has changed, it has to, like, if it's B that's changed, it has to run through the whole tree. Where in a signals library, it's not about where it's declared, it's about where it's used. So it can just jump straight to here when B updates. Okay. Yeah, I mean, it's very symmetrical. No, I don't think so. This is actually something we looked into in Marco. This is kind of the problem. It was just like, how hard is it to figure out like this mutation or whatever when you're 5 files away from where it started or where it is. And is it a mutation? I guess push is a mutation. How about some function? Is that a mutation? Like, or I think you get what I'm saying. This has actually been one of the hardest problems. This is one of the strengths why I don't think the React compiler is at all equivalent to what we're doing. Yeah, I mean, I talked about this at the beginning of the stream when I was talking about incremental computeds. If you're doing kind of batching, the problem is different parts of UI, different parts of states might actually have different batch windows. So like keeping the history of diffs is kind of like a pain in the ass. So where I'm getting to here is in Solid, we kind of avoided all this because we were like, okay, guess what? We already solved this problem. Now, passing this through is not an indicator that it can be updated. These can't be updated. If you want to set the store, you need to be like, oh, on update, whatever, set store. And to be fair, sorry, I'm missing a function wrapper. Svelte does enforce this because their state is just a variable. So if someone passes to a certain degree, like if someone passes like a value to you, you can't mutate on the other side. You can only replace it. So like, I mean, obviously that doesn't help with deep mutability, but to a degree, Svelte API is at least shallowly a guard here. I found out though that Svelte stores actually can be written anywhere, which is highly disappointing, because you have that classic immutable problem where what this does is go like I argued for a long time. You don't actually need immutability. If you want predictability, you just need to be able to do command what is it called, query command separation, because what this means is if you do it like this, all the locations in which the store is set is going to be in the scope. Yes, you're calling it down here because you pass it through props, but all the actual set store calls are happening right here. In a sense, you're making named actions. You know how like in Redux you make actions? Well, you as long as you're not passing the set store call directly, you are defining what actions are available in your UI right in front of yourself. Obviously, if you create a separate model for your store, you should do, you know, like what Joey did, where he kind of was like, okay, look, where is it? He defined an add and remove, and he came up with the separate actions, like I was showing earlier in the stream. But what I'm trying to point out here is that this has nice characteristics, but the problem is, how do you set a store, right? Like, yes, we've established that this is a way of gaining control back, so we don't have all that indirectionality. Everything is flowing top down, just like we like it, you know, like in React or whatever. We have that control. How do we actually update the store? Yeah, Vue does proxies, and in fact, the store primitive, I guess I haven't gone on and said it. The store is a proxy. That's how I'm talking about doing this. Signals are just shallow values. In Vue, you can get like a pure signal by making a shallow ref. They do have options to not do the store thing, but their default is to make everything into a signal and a store combo. And they use mutable APIs. So the dot value do equals, so dot property do equals, which I think is kind of dangerous, given, you know, what I'm showing here. Just part of this, don't get me wrong, like people have different opinions on this, and Vue obviously is bad practices to write to your props and all this kind of stuff. But like generally speaking, I've spent it's so funny. I spent so much time. I actually agree a lot with what React philosophy is. So it's always funny when I talk to people who really pro React devs, and they're always like, oh, what about this one? This? It's like, trust me, I have done this in a way that React devs should at least be able to respect, because I actually respect your same principles. It's just you can toggle the granularity of these things. Every signal is graph carries the rules of a React hierarchy, except it's more granular. It's not like we lost the unidirectional control flow, you know, it's just that our unit is smaller than a component and extends beyond components. So yes, I am talking about proxies here. If you write to a Svelte store, it warns you. You mean out of the localized scope? Because like, I actually asked Rich a while back. I was like, oh, I'm so stoked about this. If this means that I can't write to the store anywhere except in the localized scope, I'm so stoked for this. And then Rich is like, people found that confusing. When they put the stores in separate files, they expect to be able to like just import and write to them. So we didn't really like that. So maybe things have progressed since then. So yes, you can interact with small proxy wrapper or make it deeply read only. Yes, and this is Vue's tactic too. Vue has a read-only helper, or something that like basically spits the store out as read-only. I think everyone kind of needs a version of that. Yes. Yes. Snapshot's a great way of doing this. It depends. It's good for exiting the system. You shouldn't rely on it. Oh yeah, I mentioned this earlier in the stream. I never implemented in core solid. It's funny. I proposed this primitive like 3 or 4 years ago, and covered it on the stream back then. But it's a 2-liner, so I didn't actually ship it. Like you literally just make a create memo and put a signal in it, and then have the read both sides. Solid 2.0, because I'm making the actual create signal API accept functions to do this right off the bat. It'll be in it. But today, if you want to use this, I think there's a helper in solid primitives, or you can write the 2 lines yourself. Anyway, so the next question is, how do you update a store? Well, originally I was such a huge fan of Core and Mutable JS, and I thought it was like it's really tight. Like if you've ever seen solid to do MVC or even JS framework benchmark, every demo I made when I use stores, this is a proxy with all the automatic fine grained thing. It was just it was always so tight to just be like, okay, set state to dos, filter this. Like I have a bunch of like special helpers. I'm not equal this. What else is going? Because this actually removes to dos. It actually takes a list and then it runs a filter function on it. What's this one do? Edit to do, set to dos, filters again, basically when the ID, and then sets it with the new to do. There's a lot of magic. There's a whole doc section on explaining these magic rules, to dos. Like it's so terse and so powerful. You can do iteration. You do update every 10th key. You could do a whole bunch of rules. There's ranges, all these things. I was like, man, this is what I would want to use. The truth of the matter is, it's not intuitive. And it's just masking a reality that's real. See, I was really afraid of mutation, like almost too far afraid of mutation. And I didn't understand the value that I'd already solved initially by doing the separation. 90% to like 99% of the value is just in the separation. It's so funny because people always are like, oh, I like the doc get and doc set. But the problem is then you give people a way to just be like, store, like pass store. I mean, don't get me wrong, they could pass store as an array, but no one's going to do this. This encourages you to separate it and do this. If people just pass store or just pass signal around, they're going to end up with this weird problem where they're like, they can just they lose where they are. You instead of having like the rules in front of you, you've now passing signal, and then this guy over here is updating, and this one. It's a thing that React devs all like think about in their nightmares. The tuple literally just nudges people in the right direction, and basically the solution actually is really simple. You can't make it return the next value, because then you're diffing. Like if I'm like, okay, return, if it's like return, sorry, let's just copy this again. Yeah. If I just return, this, well, I'm losing all that information here because now we have to like diff through here. And if we actually want to keep references, I'd have to do some cloning and all. Yeah, this is like a full clone, but like, it's generally what you would do is you'd go like if there was other properties that didn't change on these objects, you'd be like store a equals, like here's the immutable version of this. Store.a b equals clone store.a.b c equals 7. There we go. There's the immutable version. Like, but the problem is You do all this work and you lost track of what actually changed. So, I mean, clearly there's only really one answer here. And because we know exactly C's changed. We can communicate that. These are stable references inside and out. Like we can skip through all of this stuff and get right down to the effect that we care about. And I came up with like fancy ways to obscure this. As I said, like in the current solid syntax, it would have been like A, B, C, 7 or something, you know. But this is just infinitely more powerful. We have a produce operator that does this. This is in Solid 2.0, this is going to be the general API. But what I want to point out to you is now that you have explicit setters and you've actually separated the thing, this is different semantically than the signal equivalent, because signals return the next value, stores mutate the value the way you want them to, right? So like this is all answering that universal API problem. So, and as I said, I've covered this before on stream, but let's like, if this was a signal, and I don't want to go through all that cloning again. I hope you guys that signal. But I hope you understand that like there's a version actually of signals where there's the previous value, kind of like React, but we don't need that here. So actually, you know, let's do it just for fun. My point is, you would go clone previous a. I just did the expansion here, right? A few minutes ago, the whole prive b so on, right? So these are already different worlds. This returns the next value immutably. This mutates it in any sort of wild ways. Now, I think we're getting close to. Well, I mean, you shy away from mutation for the same reason that I was trying to show here. It's easy to lose track and control of your application when you can mutate things everywhere. This is like basically the whole premise of React. And if you talk to, it's why I had to make the signals video, because when you talk to React developers, like, oh yeah, signals and two-way binding, everything's just a big mess. It jumbles around, and it hasn't been that way since we like enforced glitch-free execution and unidirectionality. And I don't want to risk it ever getting that way. So simply doing this is a very strong indicator. Mutation is fine as long as it's not everywhere. Now, MobX has a different way that you can call out specific actions, and then you can suddenly turn on mutation mode. The only reason I don't like that is because it's kind of global. I think it's even better to key your setter to your store. Yes. I called it this API in Solid produce after immer originally. But the ironic part is immer takes a mutable thing and returns something immutable. Solid actually takes something mutable and returns something mutable. It's like not nearly as fancy, at least initially. Wait until you see what I've done, and then you're going to be like, wow, this is a little bit crazy. Now, fundamentally different primitives also get you in an interesting state because there's fundamentally different ways to derive them. Because create memo returns the next value. Right? Sorry. create memo turns out, and don't get me wrong, you can put stores in memos. Memos are great for any kind of immutable kind of change. Filtering is a great example of where you would drive this, because you can have a store of signals and then you can use a memo to be like, I only want to return the 3 that match this criteria. So generally speaking, things that are like immutable, like filter, like you basically like you have a list, you get a new list. This is great. But, and this is my stream cover, there has almost never, people are only just recognizing that this is a thing. No one, people haven't really got to the point where they're like, double store, create, I don't know what this is, store, right? Like, the problem is, and I wrote an article about this, so this is probably like the 5th time I've gone over this. I'm going to get to the good stuff soon for the guys who are patient and know my stuff. But I every time I explain this, I get better. And the reason I'm explaining this is because I showed my new stuff to Tanner Lindsley, and Tanner is kind of up on solid up to here, to everything I've shown you. He knows the stuff. He was able to jump in and actually commit changes to the new signals core code base like a couple years ago when he was looking at using it for TanStack. Like he and I didn't even have to like teach him on his stuff. He just saw it and got it. I showed him my new projection stuff yesterday, and he was like, Ryan, I just don't get what you're talking about or what you're doing. So I still need to work on the explanation. So we're getting there. What about just a class? Then define message. You can call that update the signal old class message. It's an object class, so it works not calling. Well, I mean, it's fine when it's simple and it's shallow, but the class has this problem again. You're literally like to do class, list class. Like it's fine, and you can set up your own getters, which is a little clunky, but you can do that. But you end up, when you get fresh data from the server, mapping it again, because your fresh data is just objects, and then you're like, okay, well now I need to change into my reactive classes and so on. What this does that I'm showing you is stores, like something like reconcile, just spit out, just diff the changes, map the models, do all of that for you automatically as like a one-liner. So classes are fine. This, yeah, you can use decorators, but you're just talking about syntax changes over this. Right? Like you're still like, and don't get me wrong, there's places, I think from an optimize it's not just rebuilding the class. You have to actually make sure the references are the same. So if something has the same model, you actually have to do a lookup and be like, okay, do I already have this model? And now do diff the properties on it. It's not just remaking it. You actually have to do a diff. It's like, this is like, there's a good reason people went to React. I honestly, when I realized that proxies could solve the problem, like I built some of the ugliest, nastiest stuff in Knockout to solve this problem, just because I wanted those like fine-grained updates. And I feel like when people say like just use a class, it's like that same vibe or feeling. Like it's like I'm sure you could hand tailor it crazily, but then you look at the React code and it just maps, and you're just like, fuck my life. You know, so you could argue this is a bit of a DX thing, but like I was not going to suffer being even the notion that this could be worse than React in any sort of way. Yes. Yeah, and MVC, because you don't have a control, like your controller is a singleton. MVVM even has some issues there, because even though you create instances, they get shared. The only way you solve it is combine the MVVM, like the view model with the view, and package that and say, stop wrapping the model, start wrapping the view. Now, this let me cheat that. Stores are wrapping the model. Components automatically without you intercepting, like worrying about it. Components wrap the view. Yes, I definitely can see that being the case. But what if it could just be faster? Period. Okay. So, and to be fair, if you recognize that this is a category, we haven't even got into what this is. Well, the answer to this took me a long time, and this is what finally won this over to me, is a derived primitive that is store-like would also have to use mutation, right? I've called this create projection, but there's like the full axis here. Now, we'll get into projections, and that's what I showed on the stream. But before we even get to that, we actually have to talk about, I said earlier that stores aren't the same in every framework. And we should talk a bit about behavior, because I want to change the way stores work in Solid. And part of it is making this the default, but it's also um, um, looking at some of the other characteristics. And so I think we have to kind of identify, before we even get into projections, what a good store, um, like how it should um, behave. And I, I don't know, where should we do this? Excalidraw? Let's go here. Store qualities. So let's make this extra large. Yeah, okay. And then here, let's make this medium. Okay. So like, what are some qualities of stores? And I think Jovi already hit it here when talking about models, and we were talking about stable references. Stores should have stable references. Sorry, where's my scale? So let's go here. Let's start here. Stable. I'm gonna make it stable references. Okay. Solid today actually stores have stable references, but I want to kind of use this as a kind of baseline point. And I'm going to use my latest version of my stuff here. Sorry. Where is my? Did I close the whole other window? Okay, there it is. Okay, sorry. It's stuff opened up on the window I wasn't but I'm going to duplicate this. We'll get back to this eventually. I just need to use the latest version of the code here so that we can talk about this for a bit. Actually, I made a example the other day. Let me see if I can find it. I'm going to move Discord over here so I'm not. Give me 2 seconds. I'm just pulling up. The problem is I make so many solid playgrounds as examples when I'm like working on stuff. Not that one. Sorry, 2 seconds. Okay, here we go. Let's look at this. Actually, I don't want to do that. What I want to do is actually drag this into this. Give me 2 seconds. I have too many windows open. Because what I want to do is I want to grab the reactivity in this repo, which is the latest, and update. Okay, these are the same one. Imagining things. Okay. Update this one. Okay. All right. Oh, put in the wrong. Okay, cool. So let's talk a bit about the behavior on stores, because I've actually did a little research, and someone actually showed me that like Svelte does some things the same and some things different, and Vue does some things the same, some things different. It might be worth even looking at those for a minute. They can. You can put a getter in a store, so you can. I stores today, the getter has to almost be static. Like you have to define the getters like when you initialize, but and because of the path API, it doesn't make a lot of sense. But there's nothing to stop us in 2.0. I haven't just implemented it yet. Where's my example here? So I'm going to close down the incremental stuff. dbmon stuff I'm not going to need anymore. There's nothing to stop us from like inside here be like object dot define property, you know, and like add getters. I mean, obviously you can just put a function in there, but if you want it to be like seamless, like so you can just go this dot blank, and have it derived, you're gonna have to get a getter in there either through the like I didn't show it here, but stores have like a initialized object that like or array that is their base. So you can design the static version of your store here and put the getters like right in here, and then they'll read from other store properties. But otherwise, you're kind of like in this boat. Because you're basically doing, again, what Jovi was doing here, where these are getters, essentially. But the thing that this is an immutable kind of setup. Like, even though it's fine because he's only updating the thing once, but like you can still see that you're doing immutable operations here, because these are every node itself is immutable, right? Because every signal is immutable. If you, I mean, to be fair, we use this pattern a lot in Solid, but with proxies, you can actually just like do dot push instead if you wanted to, and get basically the same effect. Anyway, where was I? Yes. I wanted to talk about some characteristics of stores that I think are important. And solid stores today don't work this way completely, but I've learned that certain things are important. And the first one I want to show off, actually, there's actually two properties that I've come to think are important. I wrote down stable references, but another property that I think is actually important is probably, and we haven't done this before, I think we should talk about this, which is I call source guarding. This is tricky to do without cloning, but the thing is, if you open up Solid today and you create a store and you mutate, well, I mean, let's do it. It's a create mutable right here, but let's do this. Let's go import create store from solid JS store. It's funny, I secluded them like they were second class citizens at a certain point. But let's go here, create store. If I go, sorry, const ref equals A1 const store, create store from this reference. And then I do something like, sorry, it's an array. If I go in here and I go set store, see, we also support objects merging like React top level. So if I go A is 5 now, can you guess what happens if I console log store.a? It's 5, unsurprisingly. Sorry. What if I console log ref.a? It's also 5. So it kind of goes with the territory. You're mutating something, so the object you pass in gets mutated. Not surprising. We wrap it in a proxy for reactivity, but it mutates it. But the problem is when you have data structures and you don't set 5, you set another object. And then someone else comes in and updates that object. You're going to find that a bunch of stuff that might be nothing here get mutated. And when I created Solid originally, I was just like, I mean, it's mutating. What do you expect? But the problem is, and there's a reason, because I wanted to be able to diff it. If I clone everything here, I can't use that reconcile. I need to beat Ryan Florence in that benchmark. So if we're just gonna take the naive clone everything approach, we lose one problem is we lose references. So we can't diff. So we can't beat Ryan Florence, which is not acceptable. So I was like, I'm okay with mutating. It can't just be the initial value, because you could set, it's like you clone it as it enters, essentially, right? Right? Like it's cloning here helps, but you actually have to, the problem is, and if you're setting something, you have to kind of like deeply walk through the whole tree and find the things that are new. I mean, it's fine, I guess, at the point of replacement, but like this is only a problem when someone goes in and sets A.B. But like if you're going to clone preemptively, you actually have to kind of do a deep clone every time you hit a new property or a new object you hit. Yeah, exactly. Basically, this is worse than doing things immutable, because immutable only needs to clone things that change. I know, I joke, but that dbmon example annoyed me, because I was like, no one really actually does this. But if people are going to take signals seriously, I have to show that there's no downside compared to React. And this was one of the earliest ones that I was like, I got it. Like the mapping was annoying as hell. And I realized the proxy solved it. I think, Evan, you realized to a certain degree that proxies were good too, but I don't think he was so performance oriented. Yeah, I mean, copy on write is fine, except for it makes a pain in the ass when diffing, because your copy is never the same as the source copy, so you can't do immutable diffing. You have to do like really bad, like Angular style diffing. So like This isn't good. So I mean, I'm okay with it because it's like, look, you're in our zone now. If a lot of people, what they do is they just clone it themselves. They deep clone before they start, and then they don't worry about the after the fact because like they're kind of already in our zone by then. But a lot of people just go deep clone here, call it a day. Well, I mean, it's interesting. Like this is what I want to propose to you guys. Let's go back to new solid. So these are two properties that I wanted to kind of bring to your attention. I wanted to talk about stable references and about source guarding. Okay, there's a few other ones that we'll probably get to here. So I made a simple example. I made a store, and then this is the new API, right? So and I made the ref, and then I decided that I was just going to put the ref in two locations, and then set C also to it, self-referencing, and then update uh, the B copy with a different version for A. Okay. And then I was like, okay, what should the behavior be? So maybe I should hide the answers. Maybe it's too late. Like, should I hide the answers? Let's walk through this. Okay, so we ignore this stuff for a second. Should s dot a, well, I mean, I told you the answer here, but s dot a should equal s dot a. Okay, I agree. S dot a should equal s dot, or s dot a should equal s dot b. Now, technically, this is not true in Svelte or Immer. I don't know if this is true in Vue, but every time you assign an object into their stores, it gets cloned because they source guard. But the problem with that is now you need to synchronize. Like when you use Immer and you're like, oh, like React uses IDs for diffing, right? You have keys essentially, but Immer doesn't. Immer's like, you should normalize your data. You shouldn't have more than one copy of this object anywhere in your data structure. And Redux is like this too. It's like this whole idea of like normalization and selectors means that like when you store a bunch of models, they should be normalized by key. And then if you have them in a list, you should put those keys in an array. And then that way you don't have to do crazy array operations just to update the one thing. You know, you don't have the pass through problem, and it exists in one place. But it means that like if it ever was a case where you have to put something in two locations, you have a synchronization problem. If you update the store in one, if you update the model in one place, you got to go update it in all the other places it exists. And it doesn't really make sense when you look at something like Jovi's article where you're like I'm making a to-do list here with these models. Why the hell, like, they have an identity? Why the hell should updating in one location not update in somewhere else? And I actually posted my example, this example that I'm showing right now, on X a little while ago. Sorry, where is it? Let's go to my profile. And I was talking about how like proxies are the best because I love proxies. What's the date today? I went too far. Yeah, I showed off this demo, right? Which is basically what I'm showing you again here, right? I was playing with what I call path-based versus reference-based things, but this demo is not that important. What's important is someone shared the Svelte version of this test, and S does not equal SB. It doesn't equal the ref, which is right. But basically, you can't have the same object multiple places. It's kind of like, and they tell you that you can't do the equality match, basically. If you look at the final objects here in S, B is updated, A is not. Even though like we said, look, this is ref, assign this to thing. Like This is not how mutable JavaScript works. Look, A is not updated, even though you just assign the same thing. This is odd, right? But it's reasonable if your system is based off path. Now, I suspect Vue actually might be the same as this. I don't know if anyone knows. Should we try it? Do we have a, what is it, Vue playground, SFC playground? We want reactive. No. And we want const ref equals A1, B2, I think. Doesn't really matter. We'll see this thing. And then we go const, I don't know what to call it. S equals reactive ref. No, sorry, reactive. I guess I can assign it later to more showcase what I'm talking about. And then we want to go s dot a equals ref, s dot b equals. Did I do that wrong? Does reactive still use value? Whatever. Let's try equals ref, and then s dot b dot a equals 3, and that's console log s. Did I just break this whole thing? Okay, Vue actually does update both, and let's console log ref just for fun too. I'm like looking for the refresh button. Maybe if I go this way. There we go. Vue, okay, so Vue and Solid work the same way. They actually mutate, right? So they like old Solid 1.0, Vue mutates. Yeah, I mean, these all use proxies. What we're using here, what Svelte using, these are all the same systems, basically, except for semantics, yeah. Like, this is why I'm comparing it, because the Svelte version, ref is a proxy, yes. But the difference is, yes, this will never be true, because when you wrap something in a proxy, it's not the same identity as the original object. But this is where the stuff is weird, because their version of their different proxies are not the same. And in the end, it actually gives you different values, because the mutating B forks it from A, even though these were the same reference initially. In Vue, let's see if I can do this. The console.log s.a equals s.b. Do they keep referential? You don't have to do this. I had to do some special work to make this work. Yes. So Vue works a lot like Solid, where inside they keep proxy referential equality as well. See the tree here? So yeah, Vue's implementation is a lot like Solid 1.0. So you when you give it the proxy, these are the same objects. They're not the same as a ref, but once they're proxified, they're the same, and they basically mutate all the way through. Okay. Solve this tracking state and create a mutable reference new object. Yeah, which is problematic for diffing, which I've already established. Because my whole goal here is with stores is also as a vehicle to show that when diffing happens, like what we're solving here isn't a convenient way of grouping signals. We're actually solving the problem of incremental changes, or like the things that more granular data changes. So, okay. So yeah, views like solid, Svelte is a little bit different, but Svelte source guards, which is cool. So I was like, okay, can we do both? Can we leave the ref the way it was at 1 and 2, have A and B be updated, and yeah, I don't know why I included C, have all of these be equal to each other, yeah, and have all of them be equal to each other. So guard our sources, make them have the same identity model. And make it diffable. Sorry. So we're hitting one. I'm missing one more requirement. What concilable? And it turns out the answer is yes. It's an interesting solution. The trick is not to proxy the object, but proxy a reference to the object, which creates an extra object, ironically. But I actually benchmarked this about 6 months ago, and it was still very, very, very fast. Diffing. My threshold for this diffing thing is stick it against Inferno, like the fastest VTOM library, in a basically something like the Ryan Florence test, but tests like all the different shapes. It's called UI Bench. If you ever want to find it, it's UI Bench by Local Void. Honestly, Local Void UI Bench. Probably one of the he is like, other than Dominic Ganaway, and honestly, you could say he's probably the most prominent performance virtual DOM guy like out there. He had the fastest virtual DOM library, even faster than Inferno, like basically for the last decade. And he cares about performance in a way similar to the way I care about performance, except he's on the virtual DOM side. I have incredible respect for him. Don't get me wrong, I can't beat his framework in a pure diffing test with solid. I can obviously beat React and Preact, but this is the threshold, right? I mean, let's face it, virtual DOM's made for diffing. It's going to be hard to beat it. But if you don't think this is your primary use case, I think we have options here, right? So yeah, I just drop this in. You want to see? Yes, I store the references. You got it. Exactly. This is why I can still diff, because I store the references and also manage overrides. At diffing, yes. Specifically at diffing. This is the problem with diffing is you're assuming, and like his benchmark's really cool because he has like a bunch of like a few fine-grained ones, and so it just blows the rest away in those areas. But the problem is if you turn your problem into a diffing problem, then the solution optimized for diffing is going to win. The 99% of the problems don't need to be diffing. Think about it. If you go, here's all the data for the whole tree, go. Signals still have to diff. They still have to go, okay, where did this change? 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 Whereas, so you're doing the exact same thing as a virtual DOM, except you have this extra mechanism for communicating it. At that point, you might as well run through everything. Every other scenario, whether it's creating new stuff, whether it's updating existing stuff granularly because you know it's coming or you know it changed, signals are going to be faster, right? Because you don't create the artifacts you need for diffing. When you go to a new page, you just create the DOM. When you go, I updated this one little button text, you just update that, right? But this is what I was trying to show earlier with Knockout and why it got killed in Ryan Florence's demo. This is like I tried to optimize reasonably for the worst case. And if you look at solid DBmon, it's like right up there with Inferno or whatever. Like it's actually faster. It's probably one of the fastest implementations that's not using Canvas. That's just cheating though. So it uses some linked list stuff internally that is, I mean, I've looked at, like, there's a potential. See, Solid 1.0 was built on a more push side of push pull. Like it's push pull, but it's like everything's eager, which is fine in 99% of the cases. And it was faster than like MobX and all the stuff that was available at the time. Then in doing research for Solid 2.0, Milo realized that he could make stuff faster with a more pull-oriented system, and he actually published his work, which inspired Preact signals. And everybody since has basically copied that work. Solid 2.0 is based on Milo's original reactively work, which triggered this whole signals thing. I got to give him some credit there. Because Angular signals are roughly based off the same thing. Kind of, I mean, they went through a few different phases, and there's specific implementation, but the general push pull kind of approach. Then the solid, and then alien signals is like optimizing that through the ceiling, which, so I've been actually looking recently at updating like the solid implementation to work the same way as alien signals, but it's really just an internal detail in terms of linked list. What we're talking about today is at a much higher abstraction level, right? Building things out of signals instead of just like just the signal graph itself. Meanwhile, Milo was like, okay, I found a way to make something faster than alien signals. And that's what he's working on. And I tried to implement that in Solid. And that's actually what triggered this research, because I realized that our projections, which I'll get to in a minute, in a few minutes, will actually had a huge conceptual bug in them. And that made me re-examine what the foundations of storage should be in the first place. But yeah, Milo basically figured out that he could make a purely eager push-based system, and unless you have like dangling stuff, which you rarely have in UI because it's all ownership hierarchical, like basically the thing that we'd prove with Solid, it doesn't matter if it's eager, it's so fast. Milo basically figured out a way to get rid of the double phase, like the push and the pull. He just makes it push and keeps all the guarantees. So it's very interesting, but it was a little bit too immature, and I had to work out other problems and work my way down. But generally speaking, it is internal optimizations that don't matter to you. Yes. Well, it's push pull. Yeah. That's what I'm saying. So the difference between like Solid's, as I said, version was more push based because it's eager traditionally, but what I'm using now and alien signals is just a matter of like, did we use linked lists? Like the algorithm's different. It's not something that is particularly important other than getting the last bit of performance that you'll never see in a benchmark that does anything. Like once you hook the reactive system up to anything that actually has a cost, this overhead basically disappears. Yes, to a degree. Although to be fair, we still do good enough compared to the alternative, which is diffing. And it's funny because MobX tried to do granular arrays and stuff, and I found that my immutable approach is actually faster. So I actually changed it because I actually made a, like, view vapor, and solids render and all that fine grained rendering. I made it solids built on DOM expressions, which is a generic library that could take any signals library and make a renderer out of it. And in fact, a couple streams ago, I did that with alien signals. And I did it with Vue's original RX system about 4 years ago. Basically, I made a version of Vue Vapor back in 2021-ish. And the thing is, I did the same thing with MobX even earlier, like back in 2019-ish time period. And what I realized was that their fancy observable array primitives are actually slower than me doing the immutable stuff in those benchmarks. Yeah, yeah, I mean, I don't think we've peaked here yet. Anyway, let's continue this forward a bit. What if we have an array? So we have model 1, model 2, model 2, model 1, and we want to say that to-dos are forward, then we update the title, and then we say the to-dos are backwards, and we swap it again, right? So I'm just swapping. I'm basically swapping it, but keep in mind that these reference models inside are actually the same models. Like when we switch back to backwards, like it's kind of interesting what ends up happening here. Forward, not surprising. Backwards, not surprising. It's the same. These objects are just the same things and different things. When I console log model here and model 2, again, these are the static references. But let's look at actually the to-dos object at the end here. Oh, interesting. I wonder if I introduced a bug. Because oh, do you know what the problem is? I'm not using the I'm not using his fancy log function. Sorry, Tito helped me with this. His fancy log function, if you send a proxy to the Chrome DevTools, they will keep on updating on you. So we actually had to clone it to actually show the difference. So yeah, I'm glad I noticed this. There we go. There we go. That makes more sense. We have, after our set of mutations, we have one exclamation mark, and because I do more changes to the array down here, and we've swapped the order, right? So we actually kept our model update even when we switched it backwards here. It's interesting whether that's expected behavior or not, but it's kind of a side effect of this. Just want to talk about. And I want to show that the array prototype is still preserved, because like if you just make something to an object, like clone an array, it's not like it won't have the array prototype, or like it won't be is an array. It'll have the array prototype, but it won't be is array. There's something weird about what are they called, exotics, and to do with length is 2, right? And now what we do here, let's push the model on again, and then add an exclamation mark to the last copy of the model. And then here, as you expect, the original model, because it's the same as the first model, actually has both exclamation marks. And we have 2 copies of it. And sure enough, the length is 3, okay? So we did all this stuff. It's funny because I actually don't want to freeze it here. I almost wish that these ones were actually console.log, if you think about it, because I want to prove that these never actually changed. So if I actually change these 2 back into console.logs, you're going to see that we did all this operations, updated the title and stuff, but we never actually changed the original references. Yeah, right? Okay. Finally, Svelte does something interesting with date, which is really cool here, where if like what happened to the Svelte version? Get keyed objects. Weird. Why am I not seeing the title update? Interesting. Yeah. Yeah. look at the end result from the Svelte version. World hello 1 exclamation mark. This is I don't think this is expected, right? Like, it's arguable though, but yeah. Like, if you, do you want the models to diverge like this? I don't know. I don't think so. But what was cool about the Svelte version is when I get to this date version where I make a date, assign a date, and then I set the date time, they actually end up with different data objects. Oh no, but they do have the same. Oh, never mind. They do have the same time. So this actually is not actually that interesting. I thought that they actually forked, like, yeah. So no one can do anything about this. This is just yeah. So this actually is not interesting. I was thinking that they forked yeah. No one's going to clone the date. See, yeah. So they clone it so it doesn't have equality. But yeah, what I was getting at was this example, this last example here where I showed date object. Date is a weird internal primitive. There's nothing we can do about it. Like, this set time is not reactive. We can't control it. If someone mutates this object on us, even though it's inside the store, it's not a clone. So we can't see it. It's not like we can intercept the getter or setter. So if you use a method that updates some internal method on this, you do end up both with the same time, which is also true in Svelte. The only difference here is that, yeah, because in Svelte, I guess the date doesn't equals the date. It's true. Yeah, so they don't wrap. This is something I've been arguably going back and forth with, whether we should bother wrapping classes. Originally in Solid 1.0, we don't. It had some weird edge cases for people. I'm still on the table here, which way they go. But my point on this last example is, like, with built-in natives, built-ins with their own mutable API, there's nothing really we can do here. You have to manage this yourself. And I think this is true in all solutions. Anyways, this is kind of the base here. And we want the stable references. I think we want source guarding, and we want to be reconcilable, which means we can't just clone everything. Okay. So I implemented this, as you can see, but then I hit some kind of a little bit of fun, right? Because in solid stores, we have an unwrap method, which would just get the object underneath, and the object underneath was mutated, so you're good to go. You just literally just found the object and just spit it out, and that way you could get like the non-serialized version. But you can imagine in a system that has stable references and source guarding and reconcilable, as in diffable, keeps those references around, does all these things, you can't actually mutate anything. So how the hell are you supposed to actually unwrap? Well, I realized that semantically we couldn't have unwrap anymore. So let me see if I can open up an example here. And we're going to do the same thing again. We're going to take the latest version of the reactivity and drop that into the sample. And talk about snapshot. So the idea here is that at any point in time, while you can't unwrap a store, you should be able to get a version of it that's not reactive. And we kind of debated calling it snapshot. And the way this works is, obviously, if we create a store and then we take a snapshot, it's not going to be equal, right? Immutable and state is not equal. But immutable and ref are equal. So in this case, because we haven't changed anything, they actually match because it's the same underlying object. When we take a snapshot, we actually pass it out. Now, if we set update A, this property here on this object, then take a new snapshot, again, new immutable and state can't be the same. Old immutable and new immutable can't be the same. And new immutable no longer equals ref because you've now mutated something on it and now it needs to be cloned. If you're going to get, like, you have to actually apply the mutations. However, B is still equal between these two. So this basically keeps the references as much as it can, but when it hits a mutation, it has to clone up the tree. This is basically immer as a utility. So you can go from, as I said, internally they can be diffed. You can give it reconcile with immutable sources and diff. This is how you can get a basically immutable snapshot out of the system. Now, if you don't do any mutation and you literally just do diffing and snapshotting like this, you're not actually going to end up cloning anything. It's basically like if you're interfacing with an immutable system like Redux or Xstate, it's basically just going to it's basically only just going to update every little fine-grained signal that changes and notify that. But you're actually not going to, but your references will stay completely stable. Whereas like if you're mutating stuff yourself by hand, then because of our override system that's not like swapping out references, then technically speaking, you might end up with, you know, different references than you expect, but it'll still, because the values are different, will still work in a diff. Does that make any sense? Sorry. Class loses prototyping immutability. Yeah, that's the thing. Cloning is a pain it's a pain. I'm hoping that, like, because if there's a way to clone a class. I actually like researched it, you know, because you can go object.create, get prototype of class instance with and then assign the local instant properties on top of. But even that doesn't work with private properties. So like, I don't know if you've ever like tried to manually clone a DOM node. Like, it's not the same as just using the clone helper that they provide, because like it loses stuff. Anyway. So yeah, I mean, this is the sort of change in mindset that you end up going this way. But the reason I did all of this, let's step back because I want to get to projections now. The reason I did all this is I'm working with Milo on this push-based system, and ironically, at the exact same time, I'm working on SSR, which is a completely pull-based system. It's not even push-pull. It is sort of push-pull because the promises kind of push so that they don't waterfall. But generally speaking, I've been working on an SSR mechanism that is pull-based, essentially. It just collects the promises, and then when all the promise alls them, and then tries to pull it again, collects all the promises, promise alls them, tries to pull it again. Like, so it just kind of fills in the holes. It's not, because the only interaction in a SSR system is not human interaction, it's data interaction, which means that we can basically model it completely pull-based without like, I wanted to get Solid's run once render method on SSR as well, essentially. Even with like, because right now we work like React. You hit suspense, then we re-render, you know, which was weird. So this could solve that. But what I realized is, let me make a new playground here and kind of highlight what the problem is. What I realized was, what I realized was, sorry, I'm like back. I have so many of these like scrap note playgrounds that aren't real, but I'm gonna do another one here. Okay, it's another one of those scrap note playgrounds that aren't real. I can close a few windows here. I don't need this anymore. I need this anymore, or even the JS repaint benchmark. No. We have this situation where you have a store, and you create a store and it's got some stuff in it. I don't care what's in it. And somewhere in your UI, you have a div or something, and I don't care what it is. You have some UI, and it reads store.a, okay? And then there's also, this is a fragment, let's say, it doesn't really matter. After it, there is some component, a component that takes the store, okay? I would never pass a store like this. Like you'd have names and semantics and all this, but for my case, I'm just trying to show what this looks like. And then inside comp, you do something like, oh, actually, I need a projection here. So I go proj equals create projection. My projection is going to do a bunch of stuff, but it uses the store as the base. So it projects over the store. That's the object that comes in. And what I realized was if we didn't source guard, I'm going to go P, okay? And we did something like P.A equals 5. This is just the create computed or use effect problem all over again. Because it would render this and then get here and then update this, which actually is updating this because, if it writes through, right? And then this has to update. Now, on the server with SSR, it's too late. You've already resolved this. And in Milo system with push, it's too late. You've already resolved this, probably. So, this is just bad. I love the API and what I was doing here, but it can't be a derivation if you're mutating the source. All the examples that we've been using to date in Solid with projections look like this. Create async. Fetch stuff, right? And then I'm going to get rid of the components now for fun. And then essentially some variation of reconcile data and pass in the store. Okay. Essentially, this has been most things, because what this means is you can fetch as much data as you want, whatever, get your user list. And whenever something triggers this user list to update, it's just going to diff the data versus the previous data. And this is new immutable data. And it's not even immutable. It's not even reference shared. It's completely different. It would match. So reconcile has a key, let's say the key's ID. It'll match on the ID and then do the diffing and then spit out a store basically that does fine-grained updates. But what was happening is the reference guarding meant that the data underneath here would get mutated. Now, because create async is immutable, like a signal, no one really cares because you're replacing it every time you update. So the old value gets mutated to hell. No one's ever going to notice. And, no one's over here. So our base case when we made the incredibly performant and optimized Strello demo, basically never would run into a problem. But even here, it's kind of awkward if the source is a signal or something. It's pretty awkward if you're mutating something and just relying on the fact that this doesn't actually trigger updates. This is really bad. Conceptually. I mean, it's not bad in that in the common case, nothing goes wrong here, but it was something that I was bugging me. So that's why I started looking into source guarding and started looking into this, because I realized that if we could source guard our projections as well, we would actually finally have truly derived granular data. My previous approach looked like derived granular data, but it wasn't completely. And this is why when people ask me, oh, why do you use stores here? Why don't you just use signals? Well, when I was working with Milo, we created a firewall, which is a way to do like safe computed things. But the power of stores, and don't get me wrong, a primitive like that probably should exist. Like projections in themselves, I've covered this previously on stream, are actually a crazy thing. They're designed so that they're actually both lazy and safe from a writing standpoint. They ensure that things downstream actually run after them. So they actually are glitch free writing, unlike, so it's not like use effect, which basically reruns the whole cycle again. And they're not like create computed today, which is like, depending when it runs, you might get the updated value, you might not. Who cares? It all stabilizes. These actually create what I call a firewall, which basically contain the execution to that point and then continue after they calculate. Basically, a very like this is what inspired Milo to create the push only based system, because he realized that he could basically get firewalls for free with a push based system. So like he basically designed a world in which create projection was super performant, whereas this is one of the hardest problems generally in these systems, because you have to notify through. Like if you don't have a projection and you're listening to and 1,000 things listen to, like, are separate signals come out of here, and one signal is triggering it. Well, even if only one piece of the data changes, the naive approach to doing this would notify all 1,000 places and rerun all those computations. It's actually slow. We needed a specific solution to actually solve this. Like I call it the create selector problem. Like when you go like selected ID is 5, do you want to check all 1,000 rows, or do you want to just update the row that was previously selected and the new row that's selected? Projections solve this problem by creating this firewall mechanism, which prevents the expensive work from being scheduled. Now, this is, as I said, this is a whole other thing that I've covered previously on stream. But my problem was we weren't source guarding. That's the big change today. Yeah, structure clone does not handle classes nicely. I mean, you can have async push pull, and the client. I watched my previous stream. I don't often say this so directly, but the async model that I'm working on, or that we've been working on, and Dev's actually been a huge help on, as and a few others for Solid 2.0, which I covered in that stream, is mind blowing. It is so much like ahead of what every other framework's doing, including the stuff that just came out in Svelte. It is like it's crazy, and I'm not saying that. I was trying to. The problem with SSR is it's a different zone. Like there's no point if you pull it's overhead to deal with the push part. Like if you have to make all these like signals and do all this stuff, you're basically paying the cost. SSR wishes you could just jam all the strings together and shut up. Basically, like every little overhead is so much more detrimental. Even creating the signals is expensive during SSR. Yeah, I mean, I haven't done a stream on how push base worked, but Milo's already shown that it's basically it can beat alien signals in those benchmarks that everyone likes to talk about. That I don't think are that important of benchmarks. There's different types of benchmarks. Those benchmarks are not that important, but he basically just has a very smart graph, height-based graph traversal. I actually talked about this a bit on a couple streams ago, but we'll have a dedicated stream at some point. My point is, assuming that you have a firewall-based projection model so that this is not just create a use effect all over again, then like mutating is still a problem, is what I'm getting at. You can't derive stores from stores. Like the one thing that Insignia has going for it is you can keep the diffs going all the way through. So I had to stop and kind of walk back, and I'm not sharing all my hackmds on here, but it's been a long journey. I'm just going to throw a couple of these in, but like talking about Signia, which we already talked about, back to stores and projections, reconcile. So I went through this. I was like, well, maybe we can immutably